Hello, algebra students. Mr. Lawrence here with your next flipped lesson. This one is on what we call functions and relations. Now, this might seem like kind of weird or confusing at first, but you already have been using these. You just don't know it. For example, remember, I don't know, a few weeks ago, we had an equation like y equals, say, 2x minus 1, and you made a t-table, right? And you plugged in some x's, like I suggested you plug in 0, and if you plug 0 in for x, you get -1 for y. And then you would have graphed that point. You would have graphed the point 0, -1, right? And then some of you might have plugged in 1 for x, and 2 times 1 is 2, minus 1 is 1, and you might have plotted that point, and that would be the point 1, 1. And then, excuse me, and then you might have plugged in 2, and 2 times 2 is 4, and 4 minus 1 is 3, and that would be the point 2, 3. Now, of course, we could do this on forever and ever, but these points right here are called a relation. Why? Oh, because they're related to each other. They're all coming from the same equation. If you had, 100 points there, your relation could have 100 terms in it. But these are a relation. And every relation has two parts. It has a domain, and all the domain is the x values, okay, or your inputs. So your domain for this set would be 0, 1, and 2. And notice I wrote them numerically in order, and that is usually the most common way to do it. Well, then you also have your range, and your range are the y values. I'll bet you already knew that after I said the domain was the x values. And the range for this relation would be, say, -1, 1, and 3. Okay? So let's take a look at a couple sets of relations. I've got a couple here that will appear in a moment, and you see if you can identify the domain and the range. Okay, so I've got 4 problems here, 4 sets of relations, and I'd like you to find the domain and the range of each. All right, if you think you know already, go ahead and pause the video and see if you can come up with them. If not, go ahead and watch the first one and then maybe pause before I do the second, third, and fourth. All right, so my domain is my x values. So my domain is going to be 5, 3, and 6. Okay, now I guess it would look better if I did it this way. Let's see if I can do this. Here we go. It's going to be 3, 5, 6. Put them in sequential order, and that way the reader can tell exactly what's going on. Now my range looks like it's going to be -2 and 5. I'm not going to write it twice, the -2, even though it showed up twice. It's redundant. It's part of the range. Okay, so one of the y values is -2. All right. If you'd like to pause at this point, go right ahead, try to do the rest. If not, just keep watching. My domain for problem B looks like it's going to be 0, 1, 3, and 5. And then my range, of course, must be, 0, 1, 3, 7. 0, 1, 3, 7. All right, moving right along. It's not moving. There we go. And I'll do domain and range for the last 2 problems. I'll just go ahead and do domain for both. And for this one, it looks like the domain is 1. It's like the x value or the input is 1 every single time. From D, the domain is 2, 3, 4, 6. Okay, now the range for problem C looks like -10, -1, 2, and 4, right? And then the range for the last problem is 4. Okay, now it's important to tell if a relation is something we call a function. And you might ask, what is a function? Well, I'm going to tell you. A function is a relation, okay? But it's a very special relation. Remember, A, B, C, and D up above were all relations. But it's a relation where for every x, a member of the domain, there is exactly 1 y. So what it means is, if I list a member of the domain, it can only go to one member of the range. If I have a member of the domain going to more than one member of the range, then I do not have a function. And sometimes it's really good to visualize it like this. Sometimes people do circles like this, and they'll put the domain in the circle, and then they'll do the range over here, and they'll have -2 and then 5. And then we'll draw arrows. We'll say that, oops, wrong button. We'll say that 3 goes to -2, right, from the ordered pair. And 5 goes to -2. And then 6 goes to 5. Now check out the mapping. This is called a mapping with these two ovals. Does 3 go to more than one number? No, it only goes to -2. Does 5 go to more than one number? Nope, it only goes to -2. Does 6 go to more than one number? No, it only goes to 5. This is a function. Okay, this is definitely a function. Let's try that again, but let's try it on, say, problem C here. So I'm going to list my domain, and my domain in this case is just 1. That's it. That's the only member of the domain. The range, on the other hand, includes -10, -1, 2, and 4. And 1 goes to -10. It also goes to -1. It goes to 2. And it goes to 4. So I look at the members of my domain. For 1, does it go to more than one number? Absolutely. This is not a function. This one is not a function. It is only a relation. Why don't you test it on problems B and C? If you need to draw the mapping, as it's called, please go ahead. And then when you're ready, unpause the video and you can see what I think. Well, okay, I have mapping here for B, and as you can see, each member of the domain goes to exactly one member of the range, and that makes it a function. So B is definitely a function. Remember, to not be a function, it has to look like C, where I've got more than one arrow coming from number 1. So, problem D, I did my mapping, and again, 2 is only going to 4. 3 is only going to 4. 4 is only going to 4. This is a function. Excuse me. Each member of the domain only goes to exactly one member. All right, so that's all you're doing for homework is you're identifying the domain and range, and then a relation and a function. And that's it, ladies and gentlemen. I will say good night.